Alright, so now we want to look at being able to use the function below and answer the following questions. So we have g of x equals log base 2 of x plus 3. Want to use transformations of the graph log base 2 to graph the given function. Well, let's first think about what the parent function is going to look like. So if you remember when section 9.2, when we were looking at exponential functions, we had three anchor points. My anchor points were negative 1, comma 1 over b, 0, comma 1, and 1, comma b. So like here, if I were to graph 2 to the x, I'd have an anchor point here at negative 1, comma a half, 1 at 0, comma 1, and 1 at 1, comma 2. Now to get the graph for my log function, I just switch around the x and y coordinates. So this becomes a 1/2, so if I mark this off, 1/2, comma negative 1. This 0, 1 becomes 1, 0. This point 1, comma 2 becomes 2, comma 1. And I get a picture that looks like this. So that's my parent function. And let me just label these points. This is 2, comma 1, 1, comma 0, 1/2, negative 1. Now look at this plus 3. That plus 3 is inside with the log function. So that means this is going to be shifted left 3. So if I look at this 1/2, negative 1, I'm shifting it left 3. So I'm starting here. I'm going over 1, 2, 3. That 1, comma 0, I'm shifting to the left 3. 1, 2, 3. 2, comma 1, shift to the left 3. 1, 2, 3. And you can pick up some additional points here. Like maybe you want to do 4, comma 2. Go left 3. That goes here. And you can start drawing in your shape. Now remember, this had a vertical asymptote up here of x equals 0. That also gets shifted left to 3. So my vertical asymptote is now over here. And my graph is then extending down here, getting closer and closer to that line. Now notice what that shift has done. That's changed my domain. Instead of my domain for my log function being the positive real numbers, it's everything larger than negative 3 because I got shifted to the left 3 units. So my domain here is negative 3 to infinity. My range here is still going to be all real numbers. That doesn't change. And we mentioned that the vertical asymptote got shifted to x equals negative 3. All right, let's go and try another one. So this is log base 3. So again, kind of the same idea. I'm going back to thinking about my exponential first. So my anchor point is going to be 1, comma 1/3 on my exponential. Sorry, negative 1, comma 1/3. 0, 1, 1, comma 3. and then I'm going to switch the x and y coordinates. So now that's my parent function. Now looking at this, my transformations here is that this has been shifted 2 units to the right and 4 up. So I'm going to take these points here, shift them 2 to the right and 1 up. So if I do that negative, that 1/3 -1, so that's here. I'm going 2 to the right, 1, 2. Then I'm going up 4. 1, 2, 3, 4. So that point's now up here. 1, 0. Going 2 to the right and 4 up. 1, 2, 3, 4. And 3, 1 is here. I'm going to go 2 to the right and 4 up. My vertical asymptote gets shifted 2 to the right. So let me draw that in. And now I'm ready to draw my graph. So it's going to look something like this. And it's going to plunge down here, get impossibly close to that vertical asymptote. Now, even though I have an upward shift, that still doesn't change my range. My range is still going to be all real numbers, but my domain's been changed. We're now starting it after 2. So domain here is 2 to infinity. Range here will still be all real numbers. And we have a vertical asymptote. This time it's x equals 2.